At 3:20 in the morning UTC on Sunday, August 16th, 2026, just a day after Indonesia was rocked by a devastating magnitude 7.7 earthquake that's already killed dozens of people, the ground moved again, thousands of miles away, off the coast of the South Pacific nation of Vanuatu. A magnitude 6.1 earthquake struck roughly 56 kilometers northeast of the small coastal village of Port Olry, and within minutes it was showing up in headlines right alongside the ongoing Indonesia coverage. Two major earthquakes, back to back, on the same stretch of the Pacific Ring of Fire. If you saw both of those headlines together this week, it's completely understandable to wonder whether something bigger is happening. But here's the honest answer, and it's actually a genuinely useful one for understanding how earthquake risk actually works. This Vanuatu earthquake and the Indonesia disaster are not connected. They're not part of an escalating pattern, and by nearly every meaningful measure seismologists use, this Vanuatu event was a comparatively minor, low-consequence earthquake. Despite arriving with a magnitude number that sounds serious on its own, there were no early reports of damage. Vanuatu's own Natural Hazards Department didn't even issue a tsunami warning. The USGS's automated damage assessment system rated it at the lowest possible alert level. Today, we're going to walk through exactly what happened off Port Olry, why the depth of this earthquake matters just as much as its magnitude in determining how dangerous it actually was, why Vanuatu specifically experiences this kind of seismic activity with almost startling regularity, and how to think clearly about the difference between two earthquakes sharing a headline this week and two earthquakes actually being connected. No exaggeration, no manufactured link between unrelated events, just what the seismology tells us. Before we get into it, I want to ask you something. When you see two big earthquake headlines land within a day of each other, is your first instinct to assume they're connected, or do you usually wait to see what the actual science says? Drop a comment and let me know honestly, because I think this exact moment, two headlines colliding on the same news cycle, is one of the clearest examples of how easy it is to see a pattern that the data simply doesn't support. And if you want accurate, fast breakdowns of major seismic activity as it happens, subscribe to the channel. It's completely free, and it genuinely helps us keep doing this. A thumbs up goes a long way too. Let's get this one to 6,000 likes, so it reaches people who want the real explanation instead of a manufactured connection. All right, let's get into it. Let's start with the specifics, because they matter enormously here. The earthquake struck at 3:20 a.m. UTC, which was 2:20 p.m. local time in Vanuatu, on Sunday, August 16th. The USGS placed the epicenter approximately 56 kilometers, or about 35 miles, northeast of Port Olry, a small coastal village on the island of Espiritu Santo with a population of roughly 300 people. The magnitude was recorded at 6.1, confirmed independently by both the USGS and the European Mediterranean Seismological Center. Here's the detail that changes everything about how seriously this earthquake should be understood. The depth was recorded at 188.1 kilometers, nearly 117 miles beneath the surface. That is an extraordinarily deep earthquake, more than 18 times deeper than the shallow, catastrophic ruptures we've covered in Venezuela and Indonesia this year, both of which struck at around 10 kilometers. We've explained this principle before, but it's worth restating clearly here because it's the single most important fact in this entire story. When an earthquake occurs at a shallow depth close to the surface, the seismic energy has very little rock to travel through before it reaches buildings and people, meaning nearly all of that energy hits with close to its full destructive force. When an earthquake occurs at an intermediate or deep depth, that energy has to travel through dozens or hundreds of kilometers of rock before it ever reaches the surface, and a huge portion of it gets absorbed and dissipated along the way. A magnitude 6.1 at 188. Kilometers deep is, in practical terms, an entirely different kind of event than a magnitude 6.1 at 10 kilometers deep, even though both would be reported with the exact same headline number. This is exactly why the earthquake tracking data on this event shows it was felt by essentially nobody in any meaningful capacity, with only a single formal felt report submitted and a maximum recorded shaking intensity described as light. The USGS's automated pager system, the same tool we discussed in detail during our coverage of Venezuela's earthquake, which assigns coded alerts based on likely casualties and economic losses, rated this event at green, the lowest of 4 levels, indicating minimal to no expected casualties and minimal to no expected damage. There were no early reports of damage, and Vanuatu's Natural Hazards Department, monitoring the situation directly, chose not to issue a tsunami warning at all. If this is your first time hearing much about Vanuatu, it's worth understanding exactly why this small Pacific island nation shows up in earthquake headlines with such striking regularity, more, proportionally, than almost anywhere else on Earth. Vanuatu is a low-lying archipelago sitting directly along the Pacific Ring of Fire, at a location where the Australian plate is being forced underneath the Pacific plate along the New Hebrides Trench, one of the fastest-moving, most seismically productive subduction zones on the planet. And this isn't a slow, quiet boundary. Convergence rates here are among the highest of any subduction zone in the world, meaning stress builds up and releases far more frequently than at slower-moving boundaries like the San Andreas or even Cascadia. The historical record backs this up in a genuinely striking way. Vanuatu's largest recorded earthquake was a magnitude 7.9 event back in October 2009, and earthquakes in the magnitude 6 range like this week's occur here with remarkable frequency. Not as rare, alarming anomalies, but as a routine feature of the region's underlying geology. In fact, looking just at recent history around this exact same stretch of coastline near Port Olry, USGS records show a magnitude 6.4 earthquake striking in February of this year, magnitude 6.3 in June 2024, and a magnitude 4.6 in July of this year alone, all within roughly 50 to 90 kilometers of this week's event. This isn't a sign that something unusual is brewing near Port Olry. It's a sign that this particular junction of tectonic plates has been producing earthquakes in this general magnitude range consistently, year after year, for as long as modern seismic monitoring has existed. This is, in a way, the same lesson we covered when we talked about the Blanco fracture zone off Oregon, a fault that produces frequent, moderate earthquakes as a routine part of its ongoing geological behavior, distinct from the rare, catastrophic events that make up society's mental image of what a dangerous fault looks like. Vanuatu operates on an even more amplified version of that same principle, given how fast its subduction zone moves and how frequently it releases stress in earthquakes across a wide range of magnitudes. This is worth addressing directly, because it's almost certainly the exact question that brought a lot of people to this story in the first place, given how close together these two earthquakes landed on the news cycle. Indonesia's magnitude 7.7 earthquake struck the floor's back arc thrust, a fault system sitting behind the main subduction zone, where the Australian plate dives beneath the Sunda plate, located thousands of kilometers to the northwest of Vanuatu. This week's Vanuatu earthquake struck along the New Hebrides Trench, a completely separate subduction boundary between the Australian and Pacific plates. These are two distinct tectonic systems, driven by different plate interactions, separated by an enormous span of ocean, and crucially, by other plate boundaries and microplates in between that, effectively decouple stress transfer between them. There is no established scientific mechanism by which a rupture on one of these systems could trigger or meaningfully influence activity on the other across that kind of distance. What connects these two earthquakes isn't a shared mechanical trigger. It's the same thing that's connected nearly every earthquake story we've covered together this year. They both occurred somewhere along the Ring of Fire, the roughly 25,000-mile arc of tectonic activity that accounts for around 90% of the world's earthquakes. When you're monitoring seismic activity across an arc this vast and this consistently active, seeing multiple significant, entirely unrelated earthquakes occur within the same week, or even the same day, isn't an anomaly worth treating as a connected pattern. It's simply what an active week along the Ring of Fire actually looks like. And this particular week happened to produce two headlines that landed close enough together to make a connection feel intuitive, even though the underlying geology doesn't support one. This is exactly the same pattern we walked through earlier this year with Venezuela and Japan's unrelated earthquakes striking within the same general period. And it's worth repeating the same principle here because it's genuinely one of the most useful things to internalize about how earthquake risk actually works globally. Earth produces earthquakes of magnitude 6 or greater roughly 120 to 140 times a year, close to one every 3 days or somewhere on the planet. A week that includes two major earthquakes on opposite sides of the same tectonic arc is well within normal statistical variation, not evidence of some emerging connected global pattern. It's worth spending a moment on the USGS pager system specifically, because understanding how it works gives you a genuinely useful tool for quickly assessing the real-world seriousness of any earthquake headline you come across. Not just this one. PAGER, which stands for Prompt Assessment of Global Earthquakes for Response, automatically estimates likely fatalities and economic losses within minutes of any significant earthquake worldwide based on the earthquake's magnitude, depth, location relative to population centers, and known building vulnerability data for that specific region. It assigns a color-coded alert, green, yellow, orange, or red, that gives responders, journalists, and the public a fast, standardized way to gauge real-world severity, distinct from the raw magnitude number alone. We saw the system generate genuinely alarming, accurate projections during Venezuela's earthquake sequence in June, when PAGER assessed a real, substantial probability of the death toll climbing into the tens of thousands, a forecast that tracked to disturbingly close to what actually unfolded given the shallow depth and severe building vulnerability in the affected region. This week, for the Vanuatu earthquake, that same system produced the opposite assessment entirely, a green alert reflecting low population exposure near the epicenter, a small nearby village of roughly 1,300 people, and most importantly, that enormous 100-kilometer depth, dramatically reducing the shaking intensity that actually reached the surface. This is genuinely useful information to look for the next time you see a breaking earthquake headline anywhere in the world. The magnitude number alone tells you how much energy was released at the source. The pager alert level, when available, tells you something closer to what actually matters for real people on the ground, how much of that energy is likely to translate into real-world harm, based on depth, location, and the vulnerability of what's actually sitting above the rupture. Since we've spent a lot of time this year distinguishing routine seismic activity from genuinely significant developments, it's worth laying out plainly what would have made this Vanuatu earthquake a materially different, more concerning story, because the contrast helps clarify exactly why this one doesn't rise to that level. A genuinely concerning version of this earthquake would have struck at a shallow depth, closer to the 10-kilometer range we saw in both Venezuela and Indonesia, rather than nearly 200 kilometers down. It would have occurred closer to one of Vanuatu's more densely populated areas, such as the capital Port Vila, home to roughly 35,900 people, located hundreds of kilometers from this week's epicenter, rather than near a village of 1,300. It would have prompted an actual tsunami warning from Vanuatu's Natural Hazards Department, based on real evidence of significant vertical seafloor displacement, rather than no warning being issued at all, because monitoring showed no meaningful threat. And it would have carried a pager alert level of yellow, orange, or red, reflecting a genuine elevated statistical likelihood of real casualties and damage, rather than the green rating this event actually received. None of those conditions were present here. This was, in nearly every practical sense that matters for real-world consequences, closer to routine seismic background noise for this specific stretch of the Ring of Fire than it was to a genuinely dangerous earthquake event, despite the 6.1 magnitude number sounding in isolation, like something that should be alarming. None of this means a story like this deserves to be dismissed or ignored entirely, and it's worth explaining why we're still covering it in this kind of depth, even though the real-world impact here was minimal. First, because aftershock sequences from magnitude 6.1 earthquakes can continue for weeks to months, gradually diminishing over time, and this event will now be folded into the ongoing seismic monitoring picture for this stretch of the New Hebrides Trench, the same kind of ongoing data collection we discussed with the Brawley seismic zone swarms near the southern San Andreas. Every earthquake, even a low-consequence one like this, adds to the broader data set. Seismologists use to understand how actively this particular boundary is currently behaving. Second, and maybe more importantly, because learning to correctly read a story like this one is exactly the skill that makes you a better consumer of every other earthquake headline you'll see going forward. The ability to look past a scary-sounding magnitude number and ask the right follow-up questions. How deep? How close to population centers? What does the pager alert actually say? Is genuinely useful, transferable knowledge. It's the same skill that helped us correctly separate the Blanco fracture zone's routine activity from any real Cascadia threat, and the same skill that helps you understand why Venezuela's shallow catastrophe and Colombia's deeper, comparatively less lethal earthquake, despite similar magnitudes, produced such different human outcomes. Third, the story landing in the same week as Indonesia's genuinely devastating earthquake is a useful, real-time reminder of just how active an ordinary week can look along the Ring of Fire, and why that activity level, on its own, isn't the signal to watch for. The signal that actually matters is the one we keep coming back to across every one of these stories: depth, location, population exposure, and building vulnerability, not the sheer number of earthquake headlines appearing in the same 7-day window. If you live in Vanuatu or have family there, the practical guidance here is straightforward, and it's worth stating plainly rather than defaulting to generic advice. This specific earthquake does not appear to have caused meaningful damage or required any protective action based on the earliest available reporting and the Green Pager assessment. There's no indication of an elevated tsunami risk tied to this event, and Vanuatu's Natural Hazards Department, monitoring the situation directly and in real time, made the call not to issue a warning. That said, Vanuatu's overall long-term earthquake and tsunami risk remains genuinely real and elevated, given the country's position directly on one of the fastest-moving subduction zones on the planet. And the general preparedness principles we've discussed throughout this year's coverage apply here as much as anywhere. Know your community's evacuation routes to higher ground. Keep a basic emergency kit accessible. And treat official guidance from Vanuatu's Natural Hazards department rather than international headlines generated from a single data point as the authoritative source for whether any specific earthquake actually requires action. Here's what's worth taking away from this one. A magnitude 6.1 earthquake struck off Vanuatu this week, arriving on the news cycle just a day after Indonesia's genuinely devastating magnitude 7.7 disaster. And it's completely understandable that seeing those two headlines together raised the question of whether something larger was unfolding across the Pacific. It wasn't. These were two entirely unrelated earthquakes on two separate tectonic systems, thousands of kilometers apart. And by the actual measures that determine real-world consequences, depth, population exposure, and official hazard assessment, this Vanuatu earthquake was a comparatively minor, low-impact event, despite carrying a magnitude number that, read in isolation, sounds like it should be alarming. This is, in the end, the same lesson that's run through nearly every story we've covered together this year. A single number on the moment magnitude scale never tells the whole story. Depth matters. Location matters. What's built above the epicenter matters. And the ability to hold two things true at once, that Indonesia's earthquake this week was a genuine ongoing human tragedy deserving serious attention, while this Vanuatu earthquake, striking the same general region of the planet just a day later, was something meaningfully less severe, is exactly the kind of careful, accurate thinking that separates real understanding of global seismic risk from headline-chasing panic. We'll keep tracking activity across this entire stretch of the Ring of Fire closely, including any further developments out of Indonesia's ongoing aftershock sequence and any changes in activity near Vanuatu's new Hebrides Trench. Subscribe so you don't miss any of it, and drop a comment letting me know if you're anywhere in the South Pacific or if you have any connection to Vanuatu. Let's get this one to 6,000 likes so it reaches people who want the accurate version of this story instead of an invented connection between two unrelated events. Stay informed, and we'll see you in the next one.